Welcome to the video session on array implementation of stack in C and an application of stack conversion of infix expression to postfix form. This is Dr. Svetlin Hemlata from School of Computing Science and Engineering, VIT Chennai. It is assumed that the viewers possess basic knowledge on the concept of data structure. Now this is a pseudocode for push operation in stack and checking is full condition of the stack. In the push operation, we check whether the stack is full, and if it is full, we print an error message as stack overflow. If the stack is not full, we increment the top and we place the X, the new element, to be inserted at that location. For checking the is full condition of the stack, we check whether the top is equal to the maximum capacity of the stack. If it is equal, then full is true. So this method returns true in that case, otherwise false. Now let's see how to map the pseudocode to code in C. Here is the C implementation of push. So push takes two arguments. One thing is the stack and another one is the element to be inserted. Before seeing the definition of push, let's see how the stack is defined. Here you could see the stack is defined as a structure using the keyword struct. The name of the structure is stack. So what do we have in the stack? It's an array which can hold up to a maximum of 10 elements, and we have the top to point to the topmost element. And let's say we can define the maximum capacity of the stack as 10 using hash define preprocess statement. Now going back to the definition of push function, so here you could see a pointer variable in push, because we update the top here. Whenever you want to get the changes reflected in the calling part, we have to call by its address. Otherwise, call by value happens. So the value will be copied to a new location where whatever changes you do make in the copied content will not reflected back in the original. So in the calling part, you have to call this function by passing the address of the stack, which we are holding it in the pointer variable. So here we are using a pointer variable and the element to be inserted. So here we check first, as shown in the pseudocode, we first check whether the stack is full by calling the function is full. Again, here we pass just the value, because in is full we are not going to do any modification, so there is no need to pass the address. So we just pass the value. Value present in the address is indicated by star pointer variable. Now if is full is true, we are printing an error message stack overflow using printf function. If this stack is not full, then there are two steps. We increment the top. See how the top is accessed. Top is an element of the structure stack, and this is actually a variable, but pointer variable of type stack, if the variable is of pointer kind, you have to use an arrow operator to access any member of the structure. So here we have used the pointer variable, arrow, then the member of the structure top, and it is incremented. Then in that index of the array stack, sta is the name of the array that is acting as a stack here. So again, to access the member, sta is a member of the structure stack. Again, these members can be accessed using the pointer variable with an arrow operator. So how do we represent this? A pointer variable, point of structure kind, arrow pointer. I want to access the array sta, and the index of the array is nothing but the top. Again, the top is a member of stack, so I have to use again the pointer variable arrow operator to access the member. So this is how I could represent the topmost element in the array stack sta. In that place, in that location, the element x can be placed. So this is the definition of push. Let's see how the definition of isFull goes. For isFull, we just take a variable of type struct stack. There is no address because here we are not going to change anything inside isFull. So how do we check isFull? We all know that in C, the array index starts from 0. So if the maximum capacity is n, the array will be indexed from 0 to n minus 1. So that is what is tested here to check the full condition of stack. If top of the stack, see here you could see that I have used the structure variable s with a dot operator because it is an ordinary variable. Only for pointers we have to use arrow operator, but for ordinary variable of structure we have to use dot operator. So see how top member is accessed with the variable name dot member name. If this top is equal to max capacity minus 1, then if top is equals max minus 1, that is n minus 1, then it is full. You don't have any more space, so you return 1, otherwise you return 0. Now let's go back to the presentation. Here is the pseudocode for pop. In pop we check whether the stack is empty using stack empty method. If it is empty, we say it is error because stack underflow. Otherwise we just decrement the top value. And how the empty goes? If the top is equals 0, it is empty, otherwise not empty. Let's go back to the implementation window. Here is the definition of pop, which takes again the address of the variable, structure variable here, because I'm going to update top here. Again, whenever I am updating something inside the function and I want to have the updation reflected back in the calling part, I have to pass the address so that the change happens at that point inside the content, not in the copied content as it happens in copy by value or post by value. So here you could see inside pop we check whether the stack is empty by just passing the value. Here there is no address, I am passing the value. And if it is empty, we print the error message stack underflow by using printf function. If the stack is not empty, we just decrement the top value. Again, it is accessed by using the pointer variable, arrow, and top, and decrement by using decrement operator minus minus. Let's see how the definition of isEmpty goes. For isEmpty, I need only the variable name. I don't need the address, because here again I am not going to change any value. So here you could see only the structure variable is passed, not the address of the variable. So if the top is equals -1, because the array index starts from 0, the top value being -1 indicates that that stack is empty. So whenever the top is equals -1 means that it is empty. So in that case I return 1, otherwise I return 0. Let's move back to the presentation to see the pseudocode of top. So for top also we check whether the stack is empty. If it is empty, we print an error message as stack underflow. Otherwise we return the topmost element on the stack. Coming to the implementation part, we have the definition here. Top takes only the structure variable, again not an address, because top just returns the topmost value, no change happens inside. So it's enough to pass only the variable name. So here I'm checking whether the stack is empty. If it is not empty, I am returning the top. If it is empty, I am returning -1. I have included one more function, display, to see the contents of the stack. So again, display is not going to make any change in the content, so it's enough to pass only the structure variable and not the address. So here you could see a pass struct stack and a variable s. So for display also we have to check whether the stack is empty or not. If it is empty, I'm printing the error message stack underflow. Otherwise I'm printing the elements in the stack. So the accessible element is top, but the active elements are available from index 0 to the top, current top. So I've used a loop from I is equal to 0 and I varies up to top. Every time I is incremented, I'm just printing the value indexed by I. See here, you could see, because I have passed structure variable, how to access the member of a structure. It is using the .s.sta of I. Now we have seen the definition of all the functions record for doing operations in a stack. Now let's see the main method. So here there is a variable of structure stack kind, and here I have declared all the variables needed or used inside the program. And here you could see the declaration of all the functions. We call it as the signature of the functions. And here you could see we have to initialize the condition of empty stack, which can be done by assigning top equals -1. So the variable name is yes, and I have to use dot operator to access the member top and initializing the value of top to -1. Then I have presented different options to the users by mentioning a choice like 1 for push, 2 pop, 3 top, etc., and prompting the user to enter their choice. Since we have multiple options, I need a multi-way branching construct in C, so I go for switch construct, switch of choice. So if it is case 1, means that the user has opted for push, so I get the value to be pushed using scanf function. Then push can be called with its name push and passing two parameters. One thing is the address of the stack, another one is the value to be inserted. We know that every case in switch should have a break, otherwise all the case will be executed in a sequential manner. Now the case 2 is for pop. So for pop, I just have to call the function pop by pausing the address of the stack, that is address of the structure variable, which is yes. Then case 2 is having break as the last statement. Case 3 is for top. So for top, I have to call the function top by just passing the structure variable, not the address. Because top returns an integer value, I'm holding that return value in a variable named top value, whereas push and pop is not returning anything. So I'm checking whether the return value is -1. So the top returns -1 in case the stack is empty, that is stack underflow condition. Otherwise it will have the topmost value that can be printed. Either I can print s dot st of s dot top, otherwise I can print the top value. So both are correct because the return values are available in the variable top value. The last option is display. That can be done by calling the function display by just passing the structure variable s. As it is the last case, last choice, and you need not have break. So this is placed in the iterative setup using a do while loop. So as long as the choice is less than or equal to number 4, it can keep on giving different choices, and you can check the status of the queue by calling status of the stack by calling display function. Now let's see compiling and running this program. I could see the options displayed here. I am entering the choices 1 and value to be pushed as 10. Again I am entering the choice as 1, value to be pushed as 20. Now I have pushed 2 elements so far, 10 and 20. Let's see the status of the stack by calling display function, option 4. So here you could see 10 and 20 are getting printed. Now let's see the topmost element by using the choice 3. The topmost element is 20 because 10 was inserted first, then 20 was inserted. So in stack, the topmost one will be the recently inserted value, which is 20. Now let us try inserting one more element. So let me insert 30 and let me display. So 10, 20, 30 are the values available in the stack. Okay, so now I give 2 for deletion, that is pop operation. Now we could see the stack content by calling display function. Now 30 is not there, you have only 10 and 20. Similarly, you can do call pop again, display. Now you have only 10, 20 is gone. Now pop again, and if you try display, 10 would have been popped out. So display, when you try display, stack is empty, so you get the error message is stack underflow. Similarly, you can also check the full condition of the stack. Now let's see an application of the stack, which is infix to postfix expression. Let's go back to the presentation. Here is a pseudocode for the possible conversion. The first line says read the infix expression. So I'm going to use stack data structure for doing this conversion. So I'm not going to do any change in the functions except the type of the element present in the stack, because here infix expression is going to be on string, every content is going to be a character. So whereas we have integer there, so instead of integer array, I'm going to have a character array as a part of stack, and the top is again integer. That is the only change I made here. Then the first instruction says I have to read an infix expression. So here I'm reading an infix expression where infix is a character array of maximum of 50 characters. I'm reading this with formatting a string %yes for reading string, as infix is the name of the array, and name of the array is an address which denotes the base address. I need not use ampersand symbol as we use for ordinary variables. The next lines is an iterative part. While there are character tokens to be parsed, so you are going to parse character by character in the input infix expression, and you are going to do certain actions based on the currently parsed character. So while you have still characters to process, you have to be in the loop. So I have used while loop, and I have initialized an index variable I equals 0. So infix of I means it starts from 0th character in the infix expression, and I'm assigning that 0th value to some variable chr, and you could see I have enclosed this within the parenthesis, means that this will be evaluated first. The assignment operator would happen, then this character will be checked for the null string, that is empty character that will be appended automatically in the case of a string, null string. Till you reach that point, you have to be in the loop. So what do we do with the currently read character? If the character is an operand, you just place it in the output. Output is going to be my postfix, so I'm just placing it in the output. So here, how to check whether it is an operand? So operand, you will be having some variables. Variables will be like alphabets A to Z, can act as a variable in the expression. So I'm checking that with the ASCII value, like character greater than or equals A and less than or equals Z. That is for lowercase alphabets. Otherwise, you can also specify the variable in terms of uppercase, where the character will be greater than or equal to capital A and the character should be less than or equals the capital Z. So this is the condition for operands. So if it is an operand, I have to place it in the output. So I am initializing the index for the output array as 0 and I am placing at 0th point the first character. If it is an operand, I am just placing it and incrementing the index. If the character is an open parenthesis, just push it onto the stack. So the next condition is else if it is an open symbol, open parenthesis, I am just calling the push method by passing the address of the variable, stack variable, and then the character to be pushed, which is available in the variable chr. As if it is a close parenthesis, I have to pop all the entries in the stack except open parenthesis. Whatever I have popped should be placed in the output in the popped order. After that, pop open parenthesis also, but do not place it in the output. So if it is a close parenthesis, I have to have a looping part here, because as long as I see or until I see open parenthesis, I have to do pop, and whatever is popped is placed in the postfix. So it is like a post increment. So j value will be used, current value, because it has been already incremented here. So j value will be used for the current index in the postfix, and after that it will be incremented. So till you see open parenthesis, whatever is available in the stack will be popped. As soon as it is popped, it will be placed in the output array. Once this is done, the loop will stop with the top pointing to open. In that case, the condition fails because top is equals open. Okay, the top element is open. So you just call pop. This will remove open parenthesis from the stack, but it is not placed in the postfix output. If it is an operator, what you have to do? Suppose the stack is empty, you can directly push the character onto the stack. So the next line is else is for the operator part. If the stack is empty, it is checked by calling is empty by passing the stack variable s. If it is empty, I am just pushing the character onto the stack by passing the push method, by calling the push method. If the stack is not empty and some entries are already there, what I have to do is to check the priority of the topmost character with the priority of the currently scanned character. You cannot place a lower priority character over the higher priority character on this stack. Not even equal priority. So you have to define a function priority and assign some priority value for all the operators used. So if the priority on the top character is less than the priority of the character scan, you can push the character on the stack. So here we have, here you could see, if the priority of the character on the top is less than the currently scanned character, you can push that character onto the stack. Suppose it is not less, whatever you have on the current top is having higher priority compared to the character currently read, then what you have to do, till you find a lower priority character on the top, you have to pop that element from the stack and place that element onto the output. Finally, you could push that character scanned currently onto the stack. So that is what is done in the else part. While the priority of the currently available top character is greater or equals than the priority of the currently read character, what you have to do, pop the character and have it in the postfix array. Once this is done, it shows that the stack top contains a character which has a lower priority. So in that case, you can push the character onto the stack. Otherwise the stack may be empty also. In that case also you can push the character onto the stack. So this set of instructions are executed in an iterative fashion. Once all the characters are scanned and processed in this way, we have the characters left in the stack maybe, and few characters left in the postfix array, that is your output array. Sometimes the stack may be empty after you process all the characters in the input. Sometimes the stack may not be empty. If it is not empty, whatever is available in the stack should be, that is the last step. So if the stack is not empty, there is again a while condition, while loop. So here you just pop all the entries and place it in the output, that is your postfix. Since you are adding character by character in the output postfix expression, here you have to explicitly attach the null string to indicate the end of the postfix expression. So finally you will have the entire postfix expression in the variable postfix that can be printed. So other definitions are same as I explained before, except the change in the data type of the element to be inserted. And we also have modified the pop function to return some value, this character value, whereas in the previous case it was void, it returns nothing. So here it returns the topmost value and then update. As I told you, when you have post decrement, the topmost value, that is current value, will be used for the indexing stack array, then it will be decremented. So what should happen in pop? It has to return the current top and decrement the top to point to the next element. So I hope you got a clear idea of mapping a pseudocode to a code, especially the array implementation of stack in C, and how Infix